So our case study is located in the southwest of Germany, along the Rhine, as the name already states, Upper Rhine Valley. So mainly in the lowlands, up to the border of the Hesse federal state, more or less. And the region is quite human-shaped region, so we have a lot of interaction between the environment and humans. So there's a lot of cultural landscapes, also wine and agriculture, and also forest landscapes, which are a little bit fragmented, but still very important to supply a lot of ecosystem services to the population, including foremost maybe recreation, also being nature reserves, and for some communities still providing some timber to yeah, as an income source basically. So our focus for the case study simulations and contribution then was to look at how these multiple ecosystem services could be affected in the future under also multiple effects of risks, including, for example, drought, storm events, and also possibly bark beetle for the coniferous species that are located in the region. And this was also motivated because in the past we had two major disturbance events in 1990 and 1999. A major share of the tree species are broadleafed species in the region, including, for example, oak species, Quercus robur and Quercus petrea, then also hornbeam, Acer platanus, pseudoplatanus, and also some human-introduced pine forests. So in work package 2, we're looking at the historical effect of disturbances. So basically simulating one of these major disturbance events that I mentioned to see how this affected the forest structure in the past, and then also compare it with alternative scenarios where we have a control scenario where if the storm wouldn't have happened, and then also comparing it to alternative reality, so to say, if we would expect, for example, stronger effects of disturbances in the future to compare. So more or less to try and relate which forest attributes are most important for the resilience of these forests. And there's another task that we are involved with that is dealing with how we can increase the resilience in the future under all kinds of different stresses, including disturbances, climate change, but also societal demands, which we are exploring in work package 4. And there we are, so to say, confronting our case study forest landscape to 9 different scenarios, including 3 different climate scenarios and 3 socioeconomic narratives, so to say. So one of them is what would happen if we would increase the protected areas inside the case study area. Another one would be adapting towards what is now considered more drought-tolerant species, for example, and also changing the management towards reducing stand density, for example, to decrease competition for the remaining species. And then comparing this to a business as usual scenario to see if there would be any benefits or also what the differences would be under these alternative realities in the future, so we could still provide the forest ecosystem services for the population in the area. So we did not analyze the results thoroughly yet, but from some first analysis that I did, it looks like the business as usual scenario was actually not performing the best. It already gives us a signal that if we want to sustain the, for example, wood provisioning services as they are at the moment, some things would have to also adapt inside the forest and with forest management. I really like the diversity of people inside resonates, so it's connecting really a lot of different research institutions across Europe, and it's just a really unique working environment, which I really enjoy. Getting insights from outside your own research bubble, so to say. And I also really like the interdisciplinarity of the project because, yeah, I'm coming more from an ecological side, I would say, but we are in contact with many other researchers from social sciences, from economy also. So that's a really nice potpourri of people where you can gain new insights.